Hello everyone, this is Priyal Mansoor and today's lecture is the last lecture of the factors affecting the rate of reaction. And after this lecture, we'll be done with the rate of reaction and we're going to start the theories on it. So this is the fifth part of the rate of reaction spectrum. As we have done the nature of the reactant, concentration of the reactant, surface area, radiation, and now we'll go with the temperature. If you want to watch videos on all these factors in detail, watch the video in the description. So basically, if we talk about the temperature, we all know that when we'll increase the temperature in any of the catalyst or any of the reaction, it will produce kinetic energy and that will probably increase the rate of reaction. So if we're going to have a look on the definition, the collision model explains why chemical reaction after occur more rapidly at the high temperature. For example, the reaction rate of many reactions that occur at room temperature approximately doubles with the temperature increase by 10 degrees centigrade. Now I'll explain you the concept behind the 10 degrees centigrade very soon. Okay, first have a look at this graph. Okay, let me use a thin marker to explain it. Okay, so if you have a look on this graph, so basically it shows the difference between the low temperature reaction and the high temperature reaction. Now what is the difference basically? As you can see here at the low temperature, it probably increases at the time, but the kinetic energy is basically less. It probably do a reaction but slow reaction. But as you can see here at the right and the wide red one, if you're gonna have a look at this, it shows that the kinetic energy increases with the time as well as the reaction increases. Now basically there is a concept. The slow reaction lasts for more time as compared to the fast reaction. Fast reaction usually doesn't occur for long time. It needs more time to get stabilized. If we compare both of the reactions, we can have a look that the proportion of the particles with sufficient energy to react is here. Both of the reaction have an equilibrium state. This state is known as equilibrium state. Now basically the concept behind it is that whenever you will do the reaction on the room temperature, it will occur with the less kinetic energy and it needs more time to get at the sufficient area or EA. Let me tell you the concept behind the EA. So basically EA is the activation energy needed to start the reaction. So at the higher temperature, whenever it goes at the peak, it will start the reaction. But if we'll do it with the lower temperature, it needs more time to get stabilized. For instance, just suppose that we do have a reaction on what? We can take a reaction on the rubber. For instance, we know that to melt the rubber, we don't need a specific type of temperature, right? But it can also get melted at the room temperature as well. Now what is the difference between both of the reactions? Basically, if we provide rubber and sufficient type of temperature, just suppose that we are providing rubber 100 degrees centigrade. So it will start the reaction at that time when it gets to 100 degrees centigrade, and if we'll do it at the room temperature, it will take so much time, maybe years or maybe months. But to make it more relevant, we do need this type of rate of temperature, because when it will melt at the room temperature, it will last for more time. It will be destabilized and it will be difficult to re-stabilize it. But if we give it an instant temperature at the room as compared to the room temperature, it will basically start the reaction. That reaction would be fast reaction. We can find out the rate of the reaction, but still we can also again stabilize it. If you remember, the companies that do make the rubber do use the high temperature to make the shapes. That's the reason. If we'll melt it at the room temperature, it will be difficult to make it again at a specific shape. Apart from that, the factor of the temperature is somehow because of the collision. Because we know that the elements with the zero order do need an external energy to start the order, as well as the first order as well as the second order. They have their own reaction to start the reaction, but still they need external kinetic energy. Now I have used the term kinetic energy. Let me tell you the detail of it. So basically, whenever we'll temperate anything, it will produce kinetic energy, and because of the kinetic energy there will be collisions, right? Because of the collisions, what will happen? There would be an instant rate of reaction that will be increase in the rate of reaction. And basically, the concept behind the 10 degrees centigrade is as same. To start in reaction, and sufficient type of temperature is needed, right? Just after starting the reaction, when we'll increase the temperature to 10 degrees centigrade, what will happen? The rate of reaction will be doubled. If we'll increase 20 degrees centigrade, the rate of reaction will be tripled. 60 degrees centigrade, the rate of reaction will be fifth time. This is how it works. And this is only the factor that affects very instantly to the rate of reactions. And this is the only concept behind the factor that affects the rate of reaction. I hope that you get it, and thank you so much.